Okay, you guys, I was making lots of errors in my judgment, and so here we go. I'm going to try this again. All right, the ambiguous case. It only works with law of sign. It only happens when you have a law of sign. And what's going on is when you're told two sides and one angle, there's going to be a risk that you could actually have two separate triangles that form with the given information. So here you're told this angle is about 22.3 degrees. This side is the 7.32, and this side you're told is about 2.98. You could form this larger triangle with that given information, or if I think of it as it's going to pivot on this point right here, this side could swing back, it could swing over and form this other triangle that's in here. With this same information, this side is still 732, this side is still 298, you formed a completely different triangle. You formed the large one or this one that's in here. That's what's called the ambiguous case. I'll explain this next line right here as we start moving through the examples and doing it. So here, what you need to understand is this is asking where's your y value squared 3 over 2. You guys know that happens right here. Where's your y value that many units up? And you know that happens at 60 degrees. Where else are you the same distance up? Directly across. You're the same distance up, and that's happening at 120 degrees. Where's your y value? Square root of 2 over 2. You guys know it's right here. It's how far up you are right there. Where else are you going to have the same value? Directly across, because that's the distance up. And that's going to happen at 135 and 45. And what you guys should notice is these two angles are supplementary. They add to 180 degrees. Okay? So what happens when you have information that it's not on the unit circle? Well, you have to inverse sine this. So inverse sine of 0.25 is going to yield about, I believe it was about 14 degrees. So let's go inverse sine of 0.25. And you got, yep, it's about 14.5 degrees. There's another angle, so there's about 14.5. There's another angle that will generate exactly the same y value. And it's going to occur right here because it's directly across. This distance up is the same distance of 0.25. It has the same y value, if I wrote it as a coordinate, of 0.25, just like it does right here. How do I find that angle that creates that? They're supplementary. If this is 14.5 degrees over here, you find its supplement, so you cut it off of 180. So 180 minus 14.5 gives you 165.5 degrees. So 165.5 is another angle that has exactly the same y value. Here, if I do it, inverse sine of 0.7 gives you about 44.4 degrees. So just shy of 45. Where else is exactly the same answer? Over here. How do I find it? How do I find this other angle? Well, I cut it off of 180. I find its supplement. This angle is supplementary to this angle. So 180 minus 44.4 degrees is 135.6. The two angles are supplementary. To try and drive this point home, if I take the sine of 135.6 degrees, I'm going to get 0.7. If I take the sine of 44.4 degrees, I'm going to get 0.7. They have exactly the same y value. Okay, why is this important? Well, because when you're doing these, you're not sure what angle you're actually supposed to get. Let me set this up. So I'm going to cross multiply. I'm not using this because I don't know any information about it. Cross multiply. 7.32 sine of 22.3 degrees equals 2.98 times the sine of B. To solve for B, I have to divide both sides by 2.98. 2.98. And I get 7.32 sine of 22.3 degrees over 2.98 equals sine of B. To solve for B, I have to take the inverse sine of both sides. Type this in your calculator, and you go inverse sine 7.32 sine of 22.3. Be sure and close the paren. 2.98, and you get B is about 68.76 degrees. And using what I was doing on the previous page, so 68 degrees, where else could you have had the same y value? Directly across. So you don't know, because these could be non-right triangles, is it this angle or is it this angle? How do you find this other angle? And we're going to call it B prime. That's just a way to indicate it's the alternate version of B. I have to take its supplement. Okay, so you go 180 minus that angle, and you get 111.24 degrees, rounding nearest hundredth. Okay, that's the other angle it could be. So let's go back to this example here. If it's 68.76, then I can solve for angle C, because these two angles have to add up to 180. So ignore, I don't know why I did that. Ignoring that it could be this alternate angle, I'm just going to stick with the same way I knew nothing about the ambiguous case. I'm just going to finish this as if I didn't know anything about this. Okay, so I need to take these two angles and cut them off of 180 to get the third angle. So 180, excuse me, minus 22.3 minus 68.76. And I get this C could be 88.94. Now I can solve for angle C, and I'm just going to use this pairing right here. So I'm going to scroll this. I guess I really can't scroll down much. I'll write it over here. So C sine of 68.76 degrees equals 7.32 sine of 88.94 degrees. All right. I want to solve for side C, so I'm going to divide both sides by the sine of 68.76 degrees. Sine 68.76 degrees. So I get side C when I type that in. So that'll be 7.32 sine of 88.94 divided by sine of 68.76. And I get side C as 7.85. 1 second, guys. So that gives you the law of sine just like you have been doing it. But remember, it could have been the 111.24. So I'm going to go back and change these numbers up here. If B instead was 111.24 degrees, that gives you an entirely different angle C. You still find angle C by finding the supplement for these two angles. So I cut them off of 180. So you go 180 minus the 111.24 minus the 22.3, which gives you, oops, I didn't type in the 111, typed in 11. Okay, let's try that again. 180 minus 111.24 minus 22.3 gives you a different angle C of 46.46 degrees. So 46.46 degrees. Right? Now I solve this one just like I had here, ignoring the information I had there. I solve it just like before. I want side C, so I'm going to cross multiply. Little c sine of 111.24 degrees equals 7.32 sine of 46.46 degrees. Next. To solve for side C, I have to divide by the sine of 111.24 degrees. And that'll give rise to a brand new, or a different C. So 7.32 times the sine of 46.46. 46.46. Close it, divide by the sine of 111.24. And that gives me a new side C of about 5.69 units long. So you can see there's two entirely different triangles that get set up. And I'll return to this to how did I know that I'm going to have an ambiguous case. So let's go look at one where there isn't an ambiguous case. Setting this up, you're going to find angle B just like you have been. So 12 sine 42 is equal to 22 sine B. I need to solve for B, so I'm going to divide by 22. Then you're going to take the inverse sine of both sides. Because this is gone, so inverse sine. So inverse sine of 12 sine 42, shouldn't close the paren, divided by 22. I get B is about 21.4 degrees. If there was an angle B that was the alternate angle, I have to find its supplement. Because it's back to this idea, where's your y value? This ratio. So we found that it was at 21 degrees. Where else is it the same y value? Directly across. Okay, so we're going to find its supplement. So 180 minus that answer gives us 158.59 degrees. But what you should see right here is there's a problem. We're setting up, so here, if it's 21.4, I can find angle C by taking these two and cutting them off of 180. And that's a 4. I closed it. I apologize. So 180 minus 42 minus 21.4 degrees. And you get angle C is 116.6 degrees. Okay, 116.6 degrees. No problem. You can go on and find side C. Not an issue. Okay, where it becomes an issue is if it's instead the 158.59 degrees, there's no room to find angle C. Meaning, just to do these numbers in your head, that's about 160 degrees, and that's 42 degrees. Those two added up exceed 180 degrees. There's no room for angle C. Okay? This occurred because the very first angle you found is smaller than the angle you know. If it's smaller than the angle you know, when you go and find its supplement, there won't be room to add the original angle back on. Say it again. If the angle you find, the very first angle you found, if it's smaller than what you're told, there won't be room for its supplement and the original angle. Okay? 180 plus, oops, let me start out. Let's hit the wrong thing again. 158.59 plus the angle you're told, 42. There isn't room to get a third angle because you're automatically going to exceed 180. This was generated by this angle. This angle is smaller than what you're told. So automatically there's not going to be room for a third angle. Okay, that's the gist of the ambiguous case. Let's go back and look at this one. This is the first angle you found. It's larger than what you told. So when I find its supplement, there is going to be room with this angle and the one you're told to have an ambiguous case, to have room for a third angle. The first angle you found was larger than what you're told, so its supplement is going to be small enough to have room for the third angle. Okay, so if I go back to the first slide here, the ambiguous case only occurs when the first angle you find is larger than the angle you're told. Then you're going to have an ambiguous case. This one, whoops, has the ambiguous case because the first angle you found is larger than what you're told, so its supplement is small enough to allow for a third angle. The first angle you found is smaller than what you're told, so its supplement is too big to allow for a third angle. I think that's the last screen.